Good morning. Let me say with a few words of appreciation of the invitation which was issued by the Bulgarian friends in order to come to the country and to give several talks on the problems what I'm dealing with. This is a great challenge to teach the topics what I myself learning during the whole my career. Basically, an attempts to understand the world where we live goes back one millennium, at least more than a couple millennia, where even ancient Greeks tried to understand our environment. This understanding was very much confined, mostly by the near space around our planet Earth, which also for millennia considered like being the center of the universe. Amazingly, we just, advance this science only during last centuries. And the most important breakthrough happened last century, when we began to understand not only how vast our universe is, but also its beauty. Fantastic mechanism, fantastic energy sources operating in the universe. This tremendously broadened up our horizons. I am certainly unable to tell you the whole stories in detail. It would take many, many hours, possibly even days. I will try to focus on the most important issues, on the contemporary understanding of our space environment at large, not only in the vicinity of our planet Earth, where we live, and which belong to the quite confined area in vast space, solar system. The solar system, not saying about the Earth, it's just a tiny dot in the boundless, basically boundless universe. And I try to get you acquainted with most important ideas on modern understanding of this space environment. So the lecture is called Cosmology, Origin and Fate of the Universe. This is the main outline. I will try to pose most important scientific questions. And these scientific questions, basically, they combine not only just natural science, but also philosophical aspects. Just our attempt to answer the question, how we came to this world, and what is our future. I will try to give you the principal ideas about our views of the universe, also just the progressively growing sizes of different objects in the universe, galaxies, supergalaxies, and so on. We then address the most possibly intriguing question, and very intimate, I would say, question about the word origin. We cannot answer this question for sure, but we can right now, because of the great advances of space technology, we already just got possibly the crucial transfer from the pure speculation to the experimental basis and confirmation of our original hypothesis. Some of them were rejected, some became just, very much supported by the absolutely fantastic new findings returned back by space vehicles. And this is rooted in the historical cosmological models, and these models completely, just enriched and became even possibly more enigmatic because of the discoveries of so great entities like dark matter and dark energy. We discussing our micro world based on our understanding of the micro world, the world of elementary particles. And this is important synergy in order to advance this science cosmology. This involves several models, and I will touch upon some of these basic ideas. And this just allows us to come to our contemporary understanding of the modern cosmology and basically to ultimate fate of the universe. And this includes so absolutely, from the first sight of view, fantastic entity like our new understanding of our universe, like a part of the multiverse, and even some ideas how they communicate and how it's possible, theoretically, to penetrate from one to other. Here in the slide, I am quoting from the great scientist of last century, Albert Einstein. He said, "The most incomprehensible fact about nature is that it's comprehensible." Being involved in the field, I many times was so much impressed and so much amazed that the mankind, with their capacity to think, could penetrate so deep in the structure of matter and our world. These are displaying the main scientific goals of astrophysics to answer the three fundamental questions. First, where are we? It means structure of the universe and our location in space. As I already said, this is very, very small, just a grain in the vast space. Second question, where did we come from? And this is origin of the universe and its elements, stars, galaxies, and even more complex structures. And the third, where are we going? And this is evolution and ultimate fate of the universe as we view it right now. So, let us address the first of these three questions. Where are we? Structure of the universe as a remnant of its origin as we understand it, and our location in space. Let us start with some most important understanding understanding about distances in space. It's completely different from our everyday understanding, our everyday, dealing with some kind of the distances. We discussed, for example, how far is one city from other, but it's absolutely negligible in terms of the distances in the universe. In astrophysics, distances are measured in the light years, and this is enormous distance. It's 10 trillion kilometers. But astrophysicists usually measure in more convenient, by some reason, I will not dig too much in this, by the so-called parsecs. And this is 3.26 light years. For us, more familiar, much lower scale. This is astronomical unit. Astronomical unit is the distance of our Earth from the Sun. And this is also very, very great distance, 150 million kilometers. But in terms of the astronomical unit, say light years parsec, it's only 8 light minutes. In other words, if you just absorb a sort of flare on the surface of the Sun, it means that flare happened 8 minutes earlier. Neptune, the outermost planet of the solar system, is located at 30 astronomical units. Say, Mars, it's only 1.5, and Jupiter, only 5 astronomical units. But Neptune, the distance to Neptune, it's great. It's 4.5 billion kilometers, and light takes something like about 4 hours to reach it. Our solar system, in this scale, is quite large, but again negligible in the scale of the universe. This is distance usually measured from the Sun to the periphery of the solar system. And this is located at something like 100,000 astronomical units. And this is 1.5 light years, 1.5 parsec. The nearest to us star, Alpha Centauri, is located at 4.5 light years. And interesting, if we would use just available technologies, I mean liquid fuel or the solid fuel engines, we would take something like about 100 years in order to fly from Earth to Alpha Centauri to reach it. These scales, light years, parsec, are very small in order just to measure distances in the universe. So astronomers usually use kiloparsec, megaparsec, and even gigaparsec. Stars are located in the stellar association of some disk shape, and we call it our galaxy, Milky Way. Galaxies are the building blocks of the universe. Stars distributed in the galaxies in the absolutely not uniform structure, and maximum of the star population, the star clustering, is the galaxy center. There are in our galaxy, Milky Way, is about 200 billion stars, and it stretches for 100,000 light years or 30 parsec. Center of our galaxy, this comprises at least several billion of the Sun-like stars, and this is associated with the great, possibly you heard this, with the great black hole. How we view our galaxy? We are located near the edge of our galaxy, and it's impossible to absorb it in phase. We can absorb, located in such position, we can absorb it only edge on. And this the view of our galaxy on absorbing edge on in the visible wavelengths. But the great breakthrough enshrouded by the Earth's atmosphere when we use optical instruments on the ground. And it gave us absolutely new chances to observe the universe basically in the whole wavelengths, in the whole range of the electromagnetic radiation, from the shortest gamma rays to the radio waves. And this is how we observed in the near infrared, and this is even most possibly attractive and amazing view in the far infrared thermal radiation. And this is our galaxy as we observe it. And this is the blue color. This is dust in the plane of our galaxy. And it means when you just absorb slightly tilt of the dust, you immediately deduce that our solar system is tilted toward or just relative to the plane of galaxy of something like 60 degrees. What is our place in the galaxy? This is very interesting question. I show you this picture and you could immediately address me back with the question, oh, well, you just only said that it's impossible to absorb our galaxy just in phase, and you just displaying us such a picture. Well, you are completely right. This is not our Milky Way. This is Andromeda galaxy, which are very similar to our Milky Way. And so I displayed it just for the comparison. We are located at about 2/3 of distance from the center of our galaxy, as I said, associated with the enormous black hole, and this is our location. So, size is our solar system is only 1/10,000% of the Milky Way size, absolutely negligible, even in the scale of only our galaxies. And I will show you in a minute that our galaxy is only a member of absolutely greater scale of the whole universe. This is solar neighborhood within 1500 light years. And mostly our field, our environment around our sun is just filled up with the low density molecular gas, and this belongs to one of the spiral arms of our galaxy. And just what I mentioned, that we move, our sun is moved around the center of galaxy, and this is shown just in the direction of this movement. We call it direction toward apex. Now, we're coming to extremely interesting and challenging understanding of our structure of the galaxy among the whole universe. Galaxy form progressively growing, the clusters of progressively growing size. And these clusters range from pairs and loose groups to charmed clusters. Our local group of galaxy clusters, I mean where Milky Way belongs to, contains about 20 galaxies. And some clusters contain more than 1,000 galaxies. Clusters are something like 3 megaparsec in size, and it means that it's 100 times more than our Milky Way galaxy. 100 times larger. This is just an example of one of such cluster. It's a so-called Hickson 44, located at about 60 million light years in Leo constellation. And this is another very large cluster we call Virgo cluster of galaxies. Amazingly, the clusters form even much larger structures, and these larger structures are called superclusters of galaxies. There could be more than 100 clusters in one supercluster. And we, with our Milky Way, just a member of one of such superclusters. Size of supercluster by factor 20 more compared to the size of the cluster of galaxies. And it means its size could be something like 300 million light years, or about 100 megaparsec. This is an example, one of such supercluster, like we observe it in the radio wavelengths. This is one of the nearby, just actually nearby clusters of the galaxies around our Milky Way. Here we are with our solar system and our Earth. And this is quite familiar cluster superclusters around us, just not on the scale. This is 450 megaparsec. And, for example, constellation cluster Leo is located at something like about 150 megaparsec. Gemini, it's a bit closer, Persei, even more closer, but just very familiar, Ursa Major, is located even further. And this is also Boots, Hercules, Corona Borealis, and some others. We got absolutely fantastic chance, only during recent decades, to penetrate with our optical instruments very deep in the universe, the most possibly advanced in terms of the technology available was just at the launch of the Hubble Space Telescope. Hubble Space Telescope brought it up tremendously on our horizons and allowed us to look at the universe and the different structures in the universe, basically the close-up. And this is the image of the universe. That's the image, that's the field, filled up with just structures which looks like the stars we observe in the skies at the night time, but it's not stars. This is the galaxies and clusters of galaxies. Among the structures, we have so-called quasars or quasi-stars association. And this is the sources of enormous energy release. Quasars are associated with quite old galaxies, but which contain absolutely enormous amount of stars within their center. And this just absorbing of the matter falling down, this association with the clusters just give rise to the enormous energy release. This is one of the examples of the observable universe, how we view it in the space, mostly space telescopes. And this is just, the size of the observable universe is about 30 times more than distance between superclusters. So it's very simple arithmetics where you're getting in and you just immediately deduce just the whole size of our universe. It's more than 10 billion light years or 4 gigaparsec. I will give you more accurate figures in a few minutes. And this is just the part of the universe, like we observe it, which contain more than 1 million galaxies. Possibly one of the most impressive and even more important discoveries during the latest decade was at the large-scale structure of our universe. And this is structure which just immediately gave you an idea that the galaxies, clusters of galaxies, and superclusters are distributed within the universe, not in the uniform or a sort of chaotic shape. It turned out that they form quite well-organized structure, and you could observe it like it's a, some kind of the walls and a sort of empty place between them. This came to understanding of the large structure of our universe composed of the so-called walls astronomy, these structures are referred to like cosmic web. It's really quite well organized web of superclusters of galaxies. And as I will show you a bit later, they are associated